Now we're going to look at different ways to calculate concentration. 90% of the time in chemistry, we use what's called molarity or molar concentration. And that is moles of solute divided by liters of solution. And so the units are moles per liter, which is also your formula. And molarity is represented by a capital M. So to make 1 molar concentration solution of NaOH, I would put 40 grams of NaOH into a volumetric flask. That 40 grams is 1 mole. So 1 mole, which is 40 grams. And I know this because if you add up on the periodic table, 1 sodium, that's the molar mass, plus oxygen, which is 16, plus 1, which is hydrogen's molar mass, I would get 40 grams. So I would take 40 grams and I would stick it into my container first. Then I would top it off with enough water to reach the 1 liter mark on my container. So this would be 1 mole in 1 liter of solution. So not 1 liter of water. I don't measure the water first and then add it. Instead, I add the solid powder, 1 mole worth in this case, or 40 grams, and then I add my water until I reach the 1 liter mark. So this is how you make up a 1 molar solution. And anytime you use molarity, you always do it in this step. You get your container, you add your powder, and then you add enough water until you reach that final volume of solution. So let's look and see varying the amount of our final volume of solution does to the concentration. So in A, 1 mole divided by 1 liter, that would be a 1 molar solution. If I were double the amount of my container, 1 divided by 2 liters would be 0.5 molar concentration. And if I were to use an even smaller container, I would get 1 mole divided by 0.5 liters, 2 molar concentration. So putting this in order of highest to lowest concentration, my highest concentration is this one. So the larger the number, then I know the more concentrated it is. And then the smaller the number, then I know that that is the least concentration. So that number in front of the M tells you a lot. It tells you how concentrated that solution is. Okay, let's do a problem where we calculate the molarity. So this says 10 grams of NaOH is dissolved into enough water to prepare 750 milliliters of solution. So calculating the molarity, my formula is moles per liter of solution. So let's look at the problem. Does it tell us the moles? No, but it tells us grams. Does it tell us the liters? No, but it tells us milliliters. So I have to do 2 calculations first, and then I'll put it into my formula. So let's first calculate grams to moles of my NaOH. So there are 40 grams in 1 mole. We already talked about that, how you use the periodic table. So 10 divided by 40 grams, that would be 0.25 moles of my solute. So I'm going to go ahead and put that into my equation. Okay, now we need to calculate how many liters of solution. It tells us milliliters of solution. So there are 2 ways to do this. One way is to move your decimal over 3 places. 1, 2, 3. So that would be 0.750 liters. The liter unit is much larger than milliliters, and so when you're going from milliliters to liters, the number goes smaller because liters are so large. If this makes you uncomfortable moving the decimal, you can work it out by dividing by 1,000. So 1 liter is equal to 1,000 milliliters. So 750 milliliters divided by 1,000, I'm going to get the same answer, 0.750 liters. So I go ahead and put that 0.750 liters in my formula, and all that's left now is to divide, and I get 0.33 molar concentration. So I have 3 sig figs in that first number and 2 in the second number. So when you're dividing, you always go with the lowest number. So 2 sig figs is what I'll have with my answer. So 0.33 molar. All right, let's do another example. So again, with molarity, I'm going to write my formula. And let's look and see what we have. So it says how many grams, so this is what I need to solve for, of NaOH are needed to prepare 2 liters of a 0.6 molar sodium hydroxide concentration. So it looks like I have molarity and I have my liters of solution, so I'm going to be solving for moles. So rearranging this equation, moles equal the molarity times the liters of solution. And I can plug in the value, so 0.60 molarity times 2 liters. And actually, I'm going to change that molarity to its units, which are moles per liter. That way you can see that our liters is going to cancel out. So multiplying 0.6 times 2, we get 1.2 moles. Now, this is not what we want our answer in, because we want our answer in grams. So my next step is to convert from moles to grams. So 2 moles is equal to, I need to use a conversion factor, 1 mole equaling 40 grams of NaOH. And so I multiply out and I get 48 grams. So this is a problem that I do all the time when I'm in the lab and I need to make solutions for classes, because I know the total volume I need for all my students and I know the concentration. So I have to go through and figure out how many moles I need and then change that to grams, and then I'll put that in a weigh boat and I'll get my flask ready and I'll put that 48 grams in my flask. And then I'll top it off with water. Usually I add a little bit of water and mix and then add a little bit more. And I'll fill it all the way up, in this case, to the 2-liter mark. And so then I'll have enough solution for all my class. So I'll have 2 liters of a 0.6 molar solution for my class. Let's talk about another concentration. So this one is not as popular, but is still another way to measure how concentrated a solution is. And it's called molality. You kind of have to stick your tongue out when you say it, molality. And it's represented by this little cursive M. So molality is defined as moles of solute divided by kilograms of solvent. So this solution is put together differently. So in one container, I will measure my moles. And then in a second container, I'll measure my kilograms, and then I'll put them together. And so this will make my molal solution. So notice that it is put together differently. You measure the water, which is your solvent typically, and then you measure your solute into moles, and then you'll add them together. So the water, and you'll just stick it together in that same vessel. Problem. So molality, again, is moles over kilograms. And it doesn't look like I am given moles or kilograms. So we're going to have to make some conversions. So I do have 10 grams of the NaOH. So this is my solute. And I know that there are 40 grams in 1 mole. So I'll divide 8 divided by 40 and I'll get 0.2 moles. So this is my moles amount that I'll put there. And now we have kilograms of my water, and they only give us 450 grams of my water. So I need to convert to kilograms. So there's 2 ways to do this. I can move my decimal over 3, 1, 2, 3. So I'll have 0.450 kilograms. So kilograms are a lot larger unit than grams are. And so when you're converting, you're going to end up with a smaller number. Another way you could do this is to set it up with 1,000 grams on the bottom and 1 kilogram on the top. My grams will cancel and I'll be left with kilograms. You'll get the same answer. So whether you divide by 1,000 or move your decimal over 3, you're going to get the same answer. So dividing this out, I get 0.44 molal solution. So I have 2 sig figs right here to start with and 2 sig figs here because that 0 is just a placeholder. And so my final answer will just have 2 sig figs. So 0.44 molal concentration. You really have to be careful that you don't confuse the two. So this is a molal concentration. Let's do one more example. So how many grams of glucose is needed to add to 100 grams of water to make a 1.50 molal solution? So start with your formula. So we have moles divided by the kilograms of my water. So let's see what they give us. They give us the water. It's in grams, but we can deal with that later. And it gives us the concentration, the 1.5 molal concentration. So this one, we kind of have to work backwards. So we're going to solve for moles. So moles is equal to my molal times my kilogram. And solving for this, I get 1.50. And I'm going to take it out of the little m and put moles per kilogram. So we can see how that cancels. Next, I have my 100 grams. So I'm going to change that by moving my decimal over 3 places. So I have kilograms, and I'll multiply this out, and I get 0.15 moles. So I can't measure this on a balance. I need to change this to grams. And glucose, when you add it all up, 6 times 12, and 12 times 1, and 6 times 16, you're going to get 180. So 180 grams is equal to 1 mole of that glucose, the C6H12O6. So doing my math, I get 27 grams. So again, this one is mixed up a little bit different. So I'm going to just get a container and I'll stick in, it doesn't matter if you stick in the water first or your 27 grams of your glucose. So go ahead and add this. And then you'll measure out your water, which is your 0.1 kilogram, and you'll add that, and you'll stir it up, and that's how you make this one. So this one, you measure them separately and then stick them together.